I'm going to do that over here. Watch me do that. I'm going to cancel the M and the M and replace the GME by GRE squared. And you can see, now what happened there? If GME is GRE squared, you can now have V squared over RE equal to GRE squared over RE squared. And multiplying by RE, I can make that RE cube, and RE squared on the denominator will cancel with the RE cube, leaving a GRE. So what you see here is solving that equation gives you V squared equal to GRE, where V is the orbital speed. And therefore, what is V equal to? V equal to square root of GRE. The orbital speed, the speed that is necessary to keep an object in a low orbit. I'm not talking about a high orbit. In a low orbit is square root of GRE. We know the value of G on the surface of the Earth. We know the radius of the Earth. Therefore, we can calculate the orbital speed. Calculate the tangential velocity required to keep a satellite in a low orbit around the Earth. See, look at that low orbit. Low orbit means you can use the radius of the Earth as the distance. Well, we just obtained that equation. V orbital equal to square root of GRE, and that is square root of 9.8 times 6.38 times 10 to the 6. That's the radius of the Earth. And that is 7.9 times 10 to the 3 meter per second, which is 7.9 kilometer. So, if I can throw this ball with a speed such that in 1 second it will cover about 8 kilometers. In 1 second, if this can cover 8 kilometers, that means at that time the amount of fall of the ball will be equal to the amount of fall of the surface of the Earth. The ball will go around in that low orbit. And that is the meaning of orbital velocity. Well, we know that potential energy of a two-body system, a two-object system, depends on the distance between them. Do you know that? Well, consider the basketball and the Earth. This is a two-object system, a two-body system. When the basketball is on the surface of the Earth, we say it has the least potential energy. If I want to move the basketball away from the surface of the Earth, I need to do work. And the work I do supplies this ball with potential energy. As the distance increases, the potential energy also increases. Now, in this lesson, we will assume that the potential energy at a distance very far from the Earth is 0. Well, is that a contradiction? If potential energy at a distance very far from the Earth is 0, then what is the potential energy on the surface of the Earth? Didn't we just say that the potential energy is the least on the surface of the Earth, and it increases as we go away from the surface of the Earth? Well, if you give a proper explanation, it is not a contradiction. If the potential energy of this basketball is 0 at infinite distance from the Earth, that means if it is brought back to the Earth, as the distance decreases, its potential energy becomes negative. That means when the ball is sitting on the surface of the earth, its potential energy is negative. The maximum value of the potential energy of a two-body system is 0. When do they have the minimum potential energy? Potential energy is minimum when the objects are very close together. Potential energy is maximum when the distance between them is infinity. And we will assume that at that time the potential energy is 0. As the distance decreases, the potential energy becomes negative, more and more negative. Okay, you see, this is the same as saying that we are all trapped on the surface of the earth, which is the same as trapped at the bottom of a potential well. You know what a well is. If you jump into a well, how easy is it for you to jump out? It will be very difficult. If you know the story of the frog who wanted to jump out of a well, that frog is trapped in there for good. We are all little frogs trapped under the bottom of this potential well. Now, this is how it looks like. This is the surface of the earth, and this is that big well. And here, each one of us is trapped in that potential well. Now, the potential energy, your potential energy here is a negative value, the least. And if you are lucky enough to be out of the potential well, what will be your potential energy there? It will be 0. Now, we will be looking at a concept in this lesson. If I want to jump out of this well, what must be the velocity of my jump? What must be the velocity with which I jump so that I can get out of this well? That velocity is called the escape velocity. In other words, the velocity needed to escape the Earth's gravitational field. As long as you are in the Earth's gravitational field, you are in the potential well. Only when you are out of the Earth's gravitational field, you come out of the potential well, your potential energy becomes 0. Alright, we will talk about that as we go on. Alright. Now consider a two-body system consisting of masses m1 and m2 separated by a distance r. Because they attract each other, to move one away from the other, work needs to be done. That means the potential energy is minimum when these objects are closer together. When you separate them, their potential energy increases. As we move them apart, the work done to move them apart appears as their potential energy. Consider an object of mass m at a distance r from the center of the earth. Now look at the distance r I have used, small r. It means it is an altitude h, so that this r is re plus h. Is that right? Now here is the earth, and the object is, this is the object of mass m at a distance lowercase r from the center of the earth. To move this object, now remember, there is a force on this. What is the amount of force? The amount of force is uppercase G times MEM over RE plus H all squared. That means if I want to move this object, I need to apply a force F on it, such that F equal to G MEM over R squared. Well, what does that mean? It means that force depends on this distance R. As the distance changes, the force will also change. Now, we talked about work done by a constant force and work done by a variable force. It is easy to calculate the work done by a constant force. You simply multiply the force by the displacement. But it is much more difficult to find the work done by a variable force. The force of gravity depends on the distance r. It is a variable force. So, we need to use the method of calculus. Suppose we produce a very small displacement dr. We will assume that this force will remain a constant during that very small displacement dr. That's what we're going to do. So this force varies with distance. We will assume that this force will remain a constant in a very small interval of displacement dr. In other words, if you now want to move this object from this position to here, a distance dr, we will assume that this force will remain a constant. Therefore, the work done can be calculated as this force multiplied by that distance. Is that right? Okay, let's do that here. The work done to move the object through this small distance will be then that force multiplied by that distance. So that will be F multiplied by dr, or the force is G MEM over R squared, multiply that by dr. This is a measure of the small amount of work with a dW. Okay, potential difference between 2 points. Now what is the definition of potential difference between 2 points? If I have the basketball at this point, if I move it to a higher point, there is a potential difference between the first point and the second point. What is a measure of the potential difference? Potential difference is a measure of the work done to move the object from one point to the other. You see that? So, potential difference between 2 points is a measure of the work done on unit mass to move it from one point to the other. In other words, the potential difference is a measure of the work done per unit mass to move it from one point to the other. Let's consider 2 points A and B. This is point A at a distance r1, and this is point B at a distance r2. Now, what is therefore the work done to move this object from point A to point B? We want to move this object from point A to point B. What is the amount of work done? This is the amount of work done to move the object through a very small distance dr. So, to find the total amount of work done to move the object from A to B, we integrate this quantity from r equal to r1 to r equal to r2. And we're going to say, let ur1 be the potential at A and ur2 be the potential at B. Then, what does ur2 minus ur1 represent? That is a measure of the potential difference. And what does potential difference equal to? Potential difference is a measure of the work done to move the object from one point to the other. So ur2 minus ur1, which is potential difference between the 2 points A and B, is a measure of the total work